Logarithm of negative numbers. You might be wondering, how can we define logarithm of negative numbers when the function is itself defined for positive numbers only? So if you have seen the graph of logarithm, log function, log function is like this. This is log of x to the base a when a is greater than 1, and this is log of x to the base a when a is less than 1. So clearly this function is not defined in negative side of the x-axis. But how can we find the logarithm of negative numbers? Suppose I have to find the logarithm of -2, but our function is not defined there. Can we do anything or something which helps us to define it? So for that, we need to change our function not to an ordinary function. This will be the complex valued function now. So till now we have a real valued function. So, but in order to define the logarithm of negative numbers, we need complex valued functions. So all we need is the polar representation of a number. Consider this is the normal xy plane, normal when both x and y are real x. Now consider the complex plane. This is my complex plane. Suppose I have any complex numbers. Now I know that this can be written as, if we have z is equal to x plus iota y as a complex number, then it can also be written as z is equal to r e power iota theta. But r can be you found from the from the Cartesian coordinates, and theta can also be found from Cartesian coordinates, provided that we know in which quadrant our complex number lies. So this is how we have the polar representation. Now, if I use the polar representation of negative numbers, say -2, then I can write this e to the power iota pi. So -2 will be here, and the angle of rotation for this will be pi. So this will be a polar representation of my negative number. So if I apply log to this case, then it will be log of 2e power iota pi, right? This will be log of 2 plus log of e power iota pi. This will be log of 2 plus iota pi. So if we have any number, any negative number, any x when x is less than 0, how can we define log for that? So log of that will be, so log of x will be log of absolute value of x plus iota pi. This will be the general case for any x when x is negative. So this is actually the extension of the normal log, ordinary real valued log function to the complex function. And there are some other things to be taken care, like this, the complex function log is not a single value, it's a complex valued function, complex valued, and it's also multi-valued function. It's not a function. Actually, we have to restrict this to in order to make it as a function. But the best part is that if we have only real values, then this function is actually the ordinary log And if we have complex functions, then this is the extension of that, and this also extends to negative numbers. Hope you enjoy this.